All right, hello everyone, and welcome back to WASI walkthrough, WASI Preview2 walkthrough, sometimes call it. It's going to be mostly talking about WASI file system today. In this walkthrough, I'm hoping to get through WASI file system and WASI sockets, but at our current rate, probably won't make it through all of WASI file system and have time left for sockets today. So probably just file system stuff today. I'll probably schedule some more time. I'll figure out a time in the future to do that, to do the same thing for sockets here. So today, talking about sockets, talking about file systems. And let me just take a minute or two to get all set up on the stream here. I need to announce this thing on social media. If I can figure out my URL to post it to. Let's see. I can't figure out the URL to post it to. All right, so as I mentioned at the beginning of the stream, I'm still new at this whole social media scene. So I'm still figuring all this stuff out, and let me know how things go. All right, we got one person in the chat waving hi. That's great. Hopefully, we'll get more people saying something in the chat. In fact, one of my experiences so far in this live stream is that it feels a lot like I'm sort of like up on a stage and I can't see the audience. That's like there's no feedback. It's kind of disorienting in some ways. So the more people comment and say stuff in the chat, the more it helps me kind of realize that there's people out there. Let's see. Stream settings. I can't figure out the URL to post to stream this thing live. So I'm going to go to here, content, live stream. Here we go. So just posting this on social media. Get that link out there so people can click on it and join in on the fun. And then we will dive into WASI file system APIs. File system APIs is the biggest surface area in Preview 1. Lots of functions, and for the most part, we kind of have the luxury of basically allowing for POSIX to kind of define the functionality here. Although in some cases, we have some interesting considerations that come in for portability reasons. WASI is going to support Windows in addition to POSIX, and WASI is interested in sandboxing to a degree that POSIX isn't always interested in. And so we'll talk a bit about that with like the IDO numbers. There's an open intro with that. We can talk about that when we get there. So let's start getting ready to dive in here. Okay, I'm going to share my screen. And get into the HackMD editor here. And do the right button here. Import a file from GitHub. We're going to pull these. We're pulling them from, I have my Sunfish Code GitHub repo, mirror of all the WASI repositories. So for this live stream, I'm just editing my own local repositories. And what I'll do is after this live stream is over, I'm going to take the changes we made and submit them as proper PRs to the repositories so they can go through the usual public comment period. So we're going to WASI file system today, and I'm going to go to, I think we can go through to the README first on this one, because I think everyone knows what a file system is, or hopefully we know what file systems are if we're watching the stream. If not, that's probably more than a topic that I can introduce properly in this stream anyway. So hopefully this will make sense. Okay, WASI file system is a proposed WebAssembly system interface API. Correct phase is phase 2 in the proposal process. Champions Dan Goen, that's me. Phase 4 advancement criteria, similar to the other APIs we talked about, WASI file systems aiming to work on Windows, macOS, and Linux. We would ideally, in fact, we intend it to work on other platforms as well, and implementations have been tested on other platforms. But these are the three we call out as the absolute minimum requirements for phase 4 advancement criteria. If we can run on Windows, macOS, and Linux, we have a pretty good chance of running on most Unix-type platforms and other kinds of typical file system platforms. And we want at least 2 complete independent implementations to make sure that phase 4 standardization could move forward. But phase 4 is a ways off. We're still in phase 2. And so now we can just proceed with the design of the API. All right, so as before, this is the template page. We're going to delete some of this template content. I will be updating the table of contents offline because that's pretty boring to do on live stream. And really, we got to set up a tool to generate table of contents for us, but that's not set up right now, so I'll do it offline. All right. Just going to double check on the stream here. Sharing my screen. This looks like it's live. Yesterday, going on chat, so many questions. It's true, lots of questions on the chat, but it was actually really great. I thought that was actually really, really good. The second day was actually really good with all the questions we got talking about the WASI stream stuff. So thanks a lot for those questions, and hopefully we can do more questions today as we go through. So WASI file system is a WASI API primarily for accessing host file systems. It has functions for opening, reading, writing files, and working with directories. Capability oriented, so we basically treat directories as this kind of hierarchical set of capabilities. It's a little bit interesting, and kind of one of the base observations is that that gives us 2 things at the same time. It gives us a degree of portability, because in file systems, typically the most non-portable things happen towards the roots of the file system. So if you look at, on Unix at the / directory, you have some top-level things like /etc, /dev, /var, /temp. All these kind of things are very Unixy, and they're also things that are kind of like the top-level directories. When you get further into it, like if you have your home directory, or in particular like directories below your home directory, you have your own stuff. You can put whatever you want in there, and that's kind of like your content. It's not like Unix content, like /etc. It's your content. And so most directories outside of like the root and things that are immediately under the root, or like your home directory and things that are immediately under your home directory, are things that you define. And those are things that tend to have very hierarchical kind of organizational patterns, where access to the root directory implies access to all the subdirectories. That's kind of what we're going after here. We're kind of going after this kind of sweet spot of portability. Also in like Windows, the root directory is where we have things like drive letters, C:, and that kind of stuff. And so in C:/Windows, all the kind of things you need to know about in Windows tend to happen either at the root directory or things that are very close to the root directory. And so the focus for WASI for portable applications is kind of steer people away from, like, we don't really want WASI programs poking around in C:/Windows. We don't really want WASI programs, poking around in /etc, because these are pretty non-portable things to do. So the goal for this WASI API is to really focus on, like, what can we do to enable portable APIs? It's interesting to think about a hypothetical file system API that could focus on just like, I just want to be Unix. But I think that that's actually less urgent to focus on. Right now, the goal for WASI is to really promote portable programs and kind of like application programs rather than like system level programs that have meaningful things to do in /etc. Resolve.conf is something of a special case, but even there, I think it's worth thinking about that because of the portability concerns. But otherwise, we generally don't want WASI programs that are trying to be portable to be poking around in like /etc or other sort of well-known paths under the root directory. WASI file system hides some of the surface between Windows and Unix file systems. However, much of its behavior, including the semantics of path lookup, files, directories, symlinks, constraints of file system path is host dependent. Yeah, I think I also sort of like informally summarize this as like, WASI file system is not going to try to be a hero. It's not going to try to be like, let's try to pretend that Windows is Unix. It's not going to try to smooth over every single difference. It's mostly just going to give you the semantics of the underlying platform. So on Windows, the way that the ... paths to get to the parent directory are resolved is quite different from Unix. On Windows, those things are resolved up front at a pre-processing stage. And in Unix, the ... paths are kind of resolved along the way. So you do each component of a path at a time, and ... is kind of resolved in the place where you are in that resolution path. And so WASI just exposes the behavior of the underlying platform. There's no attempt to like redo path lookup in Windows to make it work like Unix. It's kind of just like you get what it is. And so this has potential downside in that programs that are expecting like very, very strict POSIX behavior might not get it when they're running on top of Windows. But it seems like it's the right trade-off overall. Okay. Yeah, along those lines, we're not trying to be a virtual API, and that's also a really big point. I have a blog post series that I'm writing about this, and there's a lot more to say. I'm not actually done with that series yet. There's more coming about how the everything is a file philosophy would have us take the file system API and really build it out to kind of be the general purpose access to virtual resources. And you can say like, well, you could expose all the things as files. Expose networks as files. We could expose, other kinds of communication mechanisms as files. I think that's a possible path we could take, but I think WASI is actually better served not taking that path of treating the file system as just a file system and really focusing on the strength that WASM has. That everything is a file philosophy is very much about dynamic typing and how you can coerce everything into a file, but that just means that the file has a limited set of operations, and the meaning of those operations kind of depends on what the underlying thing is. And so you sort of have to coerce everything into understanding kind of the same interface, and you start assigning meaning to underlying operations based on stuff you're doing in the files. Or in many cases, in fact, if you look at Plan 9, they end up getting into the territory of like encoding commands and writing them to special files to do certain operations. And once you're there, it's like you're not very far away from like you've just defined new functions. It's not like it's a file anymore. It's a special file that needs special commands. Long story short, I think everything as a file is not a good fit for WASI. One of WASI's strengths is to build on top of WASM, and one of WASM's unique properties is the static type checking kind of property, the fact that we have a static validation thing. That's pretty unique in a lot of systems, especially if you compare it to like native OSs where we have things like ELF, where the way ELF works is the OS just kind of maps the data into the process and starts running. In WASM, before we can run anything, we have to type check the entire code. And so this kind of ahead of time type checking gives us some interesting capabilities that we can't do in sort of native binaries. And that type checking means that we have types at a place where Unix doesn't have types. So Unix can, do everything as a file because it's at a place where it already doesn't have types. It doesn't really make sense to do anything else by just like a non-typed file interface. Whereas in WASI, we have types all the way down to the syscall interface. And so we can actually make APIs that make use of those types, and that gives us a very different design outcome than everything as a file would give us. I actually hadn't planned on talking about this at the moment. I sort of forgot this was in the README, so I'm kind of like speaking off the top of my head. Hopefully this makes sense. Goal of file system access their existing file systems in a straightforward efficient manner. And non-goals, we're not going to aim to provide deterministic semantics here. A lot of people like WASM for its deterministic properties, and that's great. And possibly in the future, we could imagine additional file system APIs in WASI that do aim to provide deterministic semantics. This might come at the cost of having less access to existing files. So if you got your existing file system out there and it's other programs are using it, we can't control things like the naming convention or other kind of conventions. But if we say like we're going to have a special directory that's only under the control of the WASM runtime, then we could potentially do things like mangle names and have certain conventions that could allow us to have more deterministic semantics that could allow us to restrict what you can do and get a sort of a file system with deterministic semantics. That's a possible thing. But the goal for a WASI file system is to say like you already have files probably, and you want to use them. You don't want to have like this separate world of files. You want to have like your existing files. So that's a compromise we make, saying like we're going to have looser semantics because we have to deal with files in the real world that we can't control, that might be concurrently modified by other processes. We can't really control what's going on there. It might be arbitrary files, most of them are arbitrary kinds of file systems with case-sensitive directories or case-insensitive directories. Might be mounted over a network. Might be, a Windows file system mounted over a network on a Unix system, so you can kind of get mixes of Unix behavior and Windows behavior mixed together. All kinds of crazy things can happen in the file system world, and WASI file system won't be able to hide it all. In fact, it's not really even going to try to hide most of it. We're just going to let it kind of bleed through and kind of let you get what it is. Because that's a trade-off, because we know we're going to get less determinism, but what we're going to get out of this is a much simpler implementation that we can actually implement this and ship it. And we think that in most cases, it'll be okay. The way most people use files is not depending on very, very subtle POSIX semantics, but just kind of depending on the fact that there's a tree of directories with files in them that more or less work. And people already tend to avoid some of the subtle, non-obvious, non-portable things. Like, people don't tend to have file names that have spaces at the end. You have spaces in the middle, that's fine, but spaces at the end, and now Windows doesn't like that. Or file names with certain names or certain odd characters, that might not work everywhere. Code that's trying to be portable typically already avoids that kind of stuff, so typically already works pretty well. Definitely not everything possible, but it's kind of a compromise. All right, so now we're going to do an API walkthrough. And I'm not going to do tons of stuff here because there's a lot of functions in the file system API, but we'll do a few use cases here just to show how using the file system at the source level works. And I think this is going to be kind of fun because with the WIT IDL that we're using, WIT actually gives us fairly nice APIs. Not the highest level APIs ever, but a little bit nicer APIs than just like calling, for example, POSIX syscalls directly. So we're going to open up, I'm going to do this in a separate tab here. The WIT API, because I don't know the whole thing off the top of my head. And so we're going to do open at okay, so use case of opening a file. Before I go in here, let's check here for questions. I sometimes lose track of questions because I'm switching tabs here and stuff like that. So let me just check the questions. Capabilities inside the file system. Once a component model is implemented, can I share capabilities from one component to a different component? That is a great question. And so image loader has no file system capabilities per default, but gets some capabilities to load an image from another component using image loader. Yes. So the answer is yes. And that, in fact, is one of the really big reasons why the capability model is good. I think actually this actually can be sometimes confusing when people look at the capability model. If you only have one component and you look at what does the capability model do within one component, and in practice, it's not that different from what you can do with a simple like path filter kind of system, saying like you can access these paths or not these paths, or even like let's rewrite these paths to virtually appear in these paths inside the WASM. That kind of a system might seem like it would work if you only have one component. But where things get really interesting is when you have multiple components and you can pass a capability from one component to another and not have to have both components have the same file system namespace. They can be in completely separate isolation from each other, but one can still say, I have this directory and I want you to access things in this directory. So I can pass you a handle to this directory. So that's actually the big reason why we're using the capabilities, is to enable that kind of like multiple components and passing handles around to represent passing authority from one to the other in a borrowing kind of way. I'm going to lend you the authority to access directory. You can do something with it, and then you return, and it's done. Without having to have an implicitly shared namespace that we're all going to share, without having to have any kind of access control for like, oh, who can access what. The handle that you pass from one component to another represents the access to access things in that directory. So great question. That's really great. Okay, so we're going to do open a file. And typically the way things work in capability systems is that you don't ever start from scratch. You always start with something. And so in this case, we're going to start from a directory. And let's see. Like code to the current API. There's some interesting questions we could talk about a little bit later, but right now the current API has a type called descriptor, which basically is a file descriptor. Although it could also be a directory because Unix allows you to have files and directories are kind of the same type at some level in Unix. So we'll say open a file, there is a directory, and we're just going to leave it at that. That'll be our function. Maybe we'll have a return type. Maybe instead just open a file, we'll say hello world is kind of a good example program for all things. And so we're going to write hello world to a file. It's like a file system hello world. So we got a directory. We're going to do open at. Start with the directory to open in. I talked in earlier days about this is so I'm gonna write this code in the sort of the style of resources where we have there is a descriptor type that has methods like .openat. That's a thing that in the current WIP engine tooling we can't quite do because we don't have the full support for resources yet, but it's coming. So I'm going to do this code right now in terms of, let's assume we have resources and we can just do this. So .openat, it's a method inside the descriptor resource. The first parameter is the AT flags. And let me look up exactly what the AT flags are. I think we don't need any AT flags, but let me just double check this. Okay. Yeah, so AT flags roughly correspond to the AT constants in POSIX. And so the only option here is simply follow or not. And so we're going to do like the typical behavior if someone asks you to open a file is that you are expected to follow symlinks. So we're going to do that. And it'll kind of show how names get mapped. So AT flags. So remember, in the WIT file, AT flags was lowercase, AT dash flags, we call it kebab case. And the reason we're using kebab case is that we want to make sure we separate the components of the words so that we generate source bindings for languages like Rust, but also C#, Go, Python, Ruby, PHP, lots of different languages out there. We want to make sure that we can map into those source languages native conventions. We don't want to have odd, like force everyone to use the snake case with underscores or force everyone to use camel case. We want to use those languages' native conventions because we want the generated bindings to be at least relatively idiomatic in those source languages. And so the AT flags gets mapped to capital AT, capital flags because that's Rust's convention. I'm writing an example in Rust right now. And it is going to be follow symlinks. That name also gets mapped. And that's our flags. So we'll pass that. All right. The next parameter to open is the path. So for this example, I'm just going to make up a path. I'm going to open up a file called reading.txt. We're going to write hello world into a file called reading.txt. Okay. That's the name. So it's relative to the directory. So inside this directory, we're going to open this file called reading.txt. The next argument is the O flags. And this is where we can also point out that in WASI Preview2, there's a number of extra arguments here. And these are called the rights arguments. So WASI Preview2 kind of splits out, for every file descriptor, there's a file descriptor, it's a set of rights of things you can do with that file descriptor. And it's very, very fine grained. It's things like, can you read? Can you write? Can you seek? Can you fsync? Can you truncate? It's like they split out every single operation. And so this is something we get from Cloud API. It's an interesting property, but it turns out in practice for the kind of use cases people have with WASI, it's not something you can really talk about in POSIX kind of programs. So we don't end up making much use of it. And like looking beyond POSIX and kind of looking towards we don't want to kind of double down on everything as a file as our unifying concept in WASI. And so it doesn't make sense to sort of like have a very elaborate set of rights on top of files that aren't going to be used for these POSIX operations. So let's go look at the O flag definition. And this is going to be similar to the POSIX O flags. So we have create, this would be like O directory, O exclusive access. and trunk. In fact, these are very similar to their POSIX names. And one of the things we can do in this stream as we go is we can rename things from POSIX if we don't like the way they spell them. This is our chance to do it. Can you highlight the changes from previous snapshot versions from the WASI file system APIs? Yeah, that's good. So I started doing that a little. I talked a bit about the writes system. So writes is going away. And sort of writes kind of took the place of, we'll have read and write access to files. That's sort of like a small version of what writes was. Writes was like that plus much more. So we're getting rid of that. The one thing that's not in this API yet that we do want to add, that I'm hoping to add real soon, that writes could do is the concept of a read-only directory. POSIX has a concept of read-only files and write-only files and read-write files. But with directories, you open a directory, and that directory handle can just do anything that you can do with the directory. So we want to add a concept of a read-only directory. That was something you could do with writes. That's useful that we can't do when we took out writes. But that's like the only thing that we know of that you could do with writes that was useful. So let's see. So yeah, so oflags, we also have this mode argument. It's going to be one of the next arguments. So we have oflags, we'll put that in. We're going to do a create. Because we're going to create that file. And it's not a directory. We don't need to fail if it already exists. And we're going to truncate it if it already exists. This is sort of the default Unix-ish behavior. If you're opening a file as an output file, you typically will create the file if it doesn't already exist. But if it does exist, you're going to truncate it and write new contents. That's what we're going to do here. I think the next argument to open at is going to be the mode. No, the file descriptor flags. And the mode will be last. Oh, I was confused before. The mode is for the file permissions. So the file descriptor flags. This is what we're going to do. So these are actually corresponding to like the rest of the O flags. O read only, O write only, O append. If you're familiar with the POSIX names, these come directly from that. So we're going to write. So we're going to do writable. So this is also a thing that doesn't exist in the preview one. Preview one sort of infers at least read, write, and append from the writes flags. Like, do you have the right to read? Do you have the right to write? And do you have the right to append? And here we're just going to give these explicit flags. Desync, non-block, rsync, and sync are all the same as they are in preview one. Non-block is a little weird here because in practice, file systems don't actually do non-blocking mode with the O non-block flag, but it's there. It will have relevance potentially when we talk about sockets. Well, that's actually, now that I'm thinking about it, why do we have this here, and is that important? Because file systems don't actually do non-blocking in practice, so maybe we should just take that out. I'm going to make a note to revisit that. This is part of the design review process, part of the process. So I kind of go through these things and think about, like, do we really need all this stuff? Okay, so we need descriptor flags. So as I said, these API bindings are going to be a little bit more convenient than preview one and more convenient than like a POSIX syscall kind of situation, but they're still a little verbose. So you got to kind of do a lot of things. It's not going to be quite as convenient as calling your typical language standard library to do stuff. So we want write. We're not going to do any appending. We don't want these sync modes. I'm not going to do an unblock. So we're just going to go. I'm going to pass in descriptor flags, and then lastly is the mode. There is an open issue on the WASI system repo about the mode here. So this refers to the permissions of the file. We're going to potentially create a new file here. And so when you create a new file, the OS wants to know what permissions to set on the file. This is a really weird question for WASI because WASI is sort of deliberately unaware of the user. if you think about programs that are portable and that are potentially not aware of your local system, they don't really have any kind of thought of who the user is and what the user can do. And they're sort of separately sandboxed separately from the user. We don't want to start with a system of like, assume you have all the rights of the user, kind of the default Unix way of doing things. We start from a place of like, assuming you have nothing and you only get what's given to you. And so the kind of concept of like a user that this file belongs to is not really a concept that WASI has. But it's turned out that it's come up in enough use cases where people want to be able to create a file and at least set the file to, for example, executable, or at least tell the file system to be read-only. And so this mode is to attempt to do that. Right now, we don't have the granularity to talk about the sort of Unix user group other is separate thing. We just have like create the file, make it readable, make it writable, make it executable, and we'll just follow the umask and set all the bits accordingly. That's something that potentially could change. There's a WASI file system issue about that we have to address. For now, I'm going to just mark this file as readable because we're going to write the contents and we want someone else to read them. And that is all the arguments: flags, path, O flags, flags, descriptor flags, and mode. Wait a minute, should I miss one? Path, descriptor flags. Oh, I didn't pass the O flags in. That's what I didn't do. O flags, descriptor flags, and mode. And then finally, the return value is a result. It's going to give us a descriptor and an error no. I'm going to take a little shortcut. Well, yeah, we'll just do it like this. To simplify things. So we'll just use the error no. That'll be referring to the WASI file system error no type. So we have enum error no. These are, you can recognize pretty POSIX error no codes. To get from this name to the POSIX name, we typically capitalize and prepend an E. Although we fixed some of the spelling, like access is an English spelling, and we might go ahead and fix some of the other spellings of these things. So this is an error no enum in the WIT, and so it'll show up in Rust as an error no type with a capital E. In the fullness of time, what we would probably define is a conversion that would convert from this error no type to the Rust standard library IO error type. And that's kind of what I was imagining using it first. But I think we're going to keep it simple for this example and just use keep it in the WASI file system API error no type. All right, so error no, we did the question mark to return the error, and this also gives us our file. So now I have the file, and what do we want to do with the file? We want to write to the file. So let's take a look at the write functions. Okay, this is in a state of transition right now. I'm going to have to do some reconciling here. In the prototype of WASI, I have hooked up, this is hooked up to the streams functionality. So we actually take a file and get an output stream, and then we could write to the output stream. That doesn't exist here in this WASI file system.wid file yet, but we do have pwrite, which is writing to an offset, which will work for our use case. So we'll do that. It's going to do a pwrite, give it a buffer to write, and we get an offset to write at, which will just use 0 because we know we're just, if there was any content before, we just truncated them. So the file should be empty. An offset within the file at which to write. Okay, so we're going to do file.pwrite. And in Rust, starting a string with B gives us a byte buffer. Here's our string. Hello world. Give it a new line. The current way the bindings work is you pass it an own string. That's something we can talk about refining over time. And then we're going to write to an offset 0. And that can also fail with an error no. So this is going to be write the string hello world to the file. But there's sort of one caveat in that like POSIX, currently the way the APIs work is that you're not guaranteed it's going to write the whole thing. It could get interrupted partway through. It's going to return us a size telling us how many bytes it actually wrote. So we can't actually have it be this simple. We're going to do a thing a little bit more complicated. And let's go ahead and put it in the comment. The world. So we're going to this loop is going to step through the string and print hopefully the whole thing. But if it doesn't do the whole thing, then we'll keep printing where we left off. If you're familiar with libc internals, this is a pretty standard thing for libcs to do, is have these kind of loops around write in order to make sure that the whole string is printed out. Most end users won't need to deal with it because they'll just use their standard library instead of talking to the API directly here. So while not view is empty, we're going to write instead of the whole string, just the view. And we're going to write it at start.offset 0. The number of bytes written, and then we're going to say increment the offset by the number of bytes written, and view so we're going to bump the view by the number of bytes written. I might be missing something, but this is basically the loop to print out the string. All right, so now we printed out the string. Our next task is to close the file, the handle we just opened. We don't want to leak a file descriptor. So we're going to look for the close function here, which is, what do we call it now? We're missing a close function. Did we forget to put that in? It's possible. This is one of those things where the meaning of file descriptor is one of the things that took a long time to figure out for WASI file system and what exactly this is and how does close work. And the fact that in the future, these file descriptor things are going to get replaced by handles, and handles will have a built-in close functionality. And so that's why we don't have any close function in here, because we're expecting that pretty soon the tools will advance to the point where they're going to provide that for us. But for now, we're going to pretend that we have a close function. Actually, it's going to be a method, isn't it? It's probably going to be actually, we can assume that the bindings can drop this thing for us, I think. These are Rust bindings. Rust has drop functions on its types. So let's just assume that the Rust is going to drop the function. So we'll add a comment for that. Just to make sure everyone knows how this is working. So there we go. We have hello world writing to a file written sort of in raw WASI. This is still pretty verbose. Most people aren't going to want to write this by hand. You're going to want to just like use your regular language standard library, which will have functionality for opening files and writing to them. But this is also quite a lot higher level than Preview1, the file API. So that's what hello world looks like. All right, let's check for questions going on here. I'm getting behind in my questions here. Does WASI guarantee POSIX unlinked semantics? That's an interesting question. In fact, it doesn't in some cases. And the reason it doesn't is because Windows. So Windows deleting things is different than Unix in a bunch of kind of fundamental ways. For example, if you have an open file, in Windows, you can't, at least without the normal way of doing things, you can't delete a file while someone else has it open. Whereas in Unix, deleting a file that's open is actually kind of a common idiom for certain kind of patterns. And so that's a thing that's not going to work as reliably in WASI just because we can't do that exact same pattern in Windows. A common use case for wanting to open a file and immediately delete it is to have a temporary file. And so what I'm expecting is that, it's not in here today, but I'm expecting that eventually WASI will have APIs for things like create me a temporary file or create me a temporary thing I can work with that can allow us to have a higher level semantics that can give the engine the ability to do, if you want a temporary file in Windows, there's a sequence of things that you should do to get it. It's different than the sequence of things you do on Unix. And if we have to follow the marching orders of a POSIX API, it'll work on POSIX platforms, but it won't work on Windows. So we need to have this like high level API, and we need to get people to use high level APIs if they want to have temporary files. It's kind of where I expect that to go. Maybe able to summarize in the docs the changes from previous snapshots. Yes. I will add some content to that right now. Okay. I'm going to put some, in fact, right after here. So I talked a bit about this earlier in the stream today. I'm just going to write some documentation about it really quickly about how Preview1 associates a set of flags with every file descriptor about what you can do with it. Yeah, so this rights flag, it comes from CloudABI, which gets it from Capsicum. My guess is that in that context, everything as a file is more important. And so they're using file descriptors and files to model more things. And in that context, it's more useful to have these kind of rights. WASI is going to be leaning away from modeling everything as files. And so we don't need to have the kind of rights at this kind of granularity. It's also worth pointing out that another replacement for rights is just general virtualization. One of the really cool properties of the component model is the ability to virtualize any API. So we can always, for any component talking to another component or talking to a host over a WIT API, we can always drop another component in between them to sort of intermediate between that component and the host. And that component could do things like enforce subsets of operations. Like I'm going to enforce that you can write but not truncate, or append but not truncate, or any kind of a policy that you want to have. Like we can drop a whole component in the middle to kind of enforce those kind of policies. A little heavier weight than rights, but it's also a lot more powerful. You can do a lot more things than just having like, here's a set of up to 64 operations that you can either say yes or no. We can have arbitrary logic sitting between you and the actual file system to kind of do that filtering. So I think that's the interposition kind of technique of like, let's drop a library in the middle is going to be WASI's big picture answer to this. Of like, if you want to have full control over what a component is doing, we can drop in adapters to fully control everything that goes in and out. If you just want to have something lightweight, in that case, typically the things that we want to do is just make something read-only. So we already have the ability to have read-only files. That's already there. And so the only thing that we're missing that we're going to need to add that's not in the API today, and I won't be able to add it in the stream today, but like I'm hoping to add it soon, is read-only directories. Okay. I think that's the biggest change so far. Oh, I guess there. So we have the mode, and at least in terms of open, that's kind of the major change here. All right. I think so. This also gives us a chance to kind of show the enum. Like we looked at flags a bit. We haven't looked at enums very much, but it was in there because we looked at it now a bit. We got kind of a taste of the API. I'm trying to think of like what's another example to kind of show off. That's not a very big example, but kind of show off how this works. Reader. This is worth pointing out. If anyone here has actually worked with the Preview1 reader function, it's pretty hairy. You have to deal with this buffer and this struct being written to this buffer of bytes, and potentially it's an array of struct, but it's a sort of variable length elements because the string is packed in the array along with the struct. And it's always really confusing what happens with the alignment inside that struct and where things go and what happens if you have a partial entry that doesn't fit the buffer. There's been a lot of questions about that, and it's just always been really confusing. This reader design in Preview 2 is just much simpler, and I think it's going to be a lot better for everyone involved. So now we have reader. It's a method on directory. It's going to be, we're just going to read entries from a directory, and then each time you call reader, you get a single directory entry. It's like an iterator over directory entries. So that's a significant change from Preview 1. That's going to eliminate all these questions about how does the reader function work. And it also eliminates the cookie part. So Preview 1 also kind of inherits this part of Unix where you have functions called seekdir and telder, where you can have a concept of a position that can seek around within a directory. This concept actually doesn't turn out to map onto modern operating system file systems very well. Modern file systems have moved way beyond the idea of having a single linear table with an offset that you can march through. File systems actually are storing their data in much more sophisticated data structures these days. So the idea of having a single integer represent your position in a traversal through a directory is something that they actually have to do a significant amount of work to emulate. And so here we just have a single reader. In fact, this is not also in here. I need also make a note to fix this. This API is currently written, does not have a way to rewind, but that's kind of the idea. So instead of having the ability to seek around to specific positions, we'll just have a way to, reader will read through successive entries, and there'll be a way to rewind back to the beginning. So we're just going to have that ability. And it's possible to emulate the Unix sort of seekdir functionality on top of that. It won't be the most efficient thing in the world, but I think this API is going to be much simpler because what we found out from WASI Preview1, in fact, is that almost no one uses seekdir in practice. It's just not very, in fact, it's very, very difficult to use seekdir correctly because if the directory can be modified while you're working on it, seekdir can do strange things. So this reader function is sort of worth calling out. Maybe I'll put an example for that here in the use case as well. This API, oh, okay. Yeah, so this API is a little bit out of date with my current thinking. So it's returning a stream of dir entry. And stream is referring to the component type stream type, which is actually part of the async proposal. So we won't be able to use stream. This will need to get redone. That's a bit more than I'm prepared to do on the stream live today, but the basic vision for redirectory is essentially like this. It's going to be an iterator kind of API where you can request directory entries. So I'm just going to say, for now, to do implement this example here. Let's go back to the questions here. Okay, in fact, I didn't even finish my previous batch of the questions. So summarize preview 1. I'm working on that here. So follow symlinks, more low-level details. Do we want to expose this to WASM? My sense is that it's worth exposing follow symlinks to WASM. There are programs that explicitly don't want to follow symlinks, and programs that I think the default expectation for users is that programs will follow symlinks. If you are in Unix and tell a program to write to a file and that file is a symlink, the default thing that most programs will do is to follow the symlink. It's sort of the default behavior. And then there are also programs that don't want to follow symlinks because maybe they have security considerations, or maybe they know what the symlinks could mean and they don't want to follow them. So I think it's useful to have follow symlinks. This is just, the things I'm saying here are just kind of my judgments and my think about things. If people have interesting reasons for why we should do things one way or another, I'm certainly open to listen to them. You don't expose something like file symlinks. You can't output whole file systems. Yes. Okay. Windows finally added for unlinked semantics to late Windows 10. But yeah, exactly. Windows does over time has been adding things that kind of get us more Unixy. But in general, I don't think we want to restrict. If we're going to say WASI supports Windows, we can't say that you have to use particular versions of Windows 10 or later at this point. There may be a day where we can do that, but that's not today. Aside from sharing issues, Windows move file ex, also with Atomic. Yeah, Atomic operations. Yeah. Imposition is really nice. Great. Pre-opens are still in Preview 2. Yes. Yes, exactly. So pre-opens are still in Preview 2. And that's not technically part of the file system API. I can actually show an example of that, where that shows up. Version reader with optional file metadata, so Windows doesn't get hosed. Yes. Let me talk about those two things. So pre-opens. So one thing we don't have yet at the WASI subgroup level is we don't yet have a proposal for the command world. So if you've been watching the path to components, or if you've been watching the developments in earlier streams that I talked about what world files are kind of like collections of interfaces. And so the command world is going to be a collection of APIs, including file systems, sockets, clocks, random, kind of all the things we're talking about today are kind of like part of the command world. And world's going to give us a way of organizing APIs. So we have, if you also seen WASI proposals for things like WASI PubSub, and WASI Key Value Store, and WASI Messaging, these kind of things. WASI as a term is going to grow to have lots of different kinds of APIs. And worlds are the ways we can use to define interesting sort of groups of those APIs, subsets of the APIs that can apply to particular domains. So WASI command will be APIs that are typically available to command line programs. Then, of course, embedders are always welcome to take those world files and extend them or modify them in some ways. You can say it's a command world plus I want to have some special API in this command. Or it's like I'm a WASI Cloud might have a world saying it's WASI Cloud, which has like the PubSub and key value stuff in it. But it also might add additional APIs on top of that if you have your own host embedding. So the worlds kind of give us this kind of way of organizing things. And that's a fairly recent development. And we don't yet have a WASI subgroup level proposal for the command world. So that's something we should fix. I'm going to make a note of that. Propose WASI command world at the subgroup level. So everything we're doing here, there's a process here. This is all going through the WASI subgroup, which is a subgroup of the WebAssembly community group, which is a W3C community group. So there's a way that everything here we're doing is fitting into, like funneling into a standards process. And so like today you'll see me making arbitrary choices about what we're doing, but eventually this will get fed up into, there's public repositories where people can comment on things. There's beyond that, there's like a voting process for advancing proposals beyond the stages. And beyond that, there's the CG is going to vote on things at some point. And then beyond that, we can actually have like an official standard come out of this thing. That's a ways away, but that's kind of the process by which these things will percolate up. So with that kind of context, I and others are working on a prototype of all these APIs in the this repository called Preview2 prototyping. And so we have the WIT files. These are basically the same, or largely the same. I still have some syncing to do to sort of sync these up with the ones that are in the public repos of the APIs. And so we have, in this Preview2 prototyping directory, we have a host implementation of these APIs that we're working on. And this also includes WASI command.wit, which is what I'll use to propose we have at the subgroup level. And you can see what's going on in this world is we have, first of all, we import all the APIs that are part of this world. So it's got clocks, default clocks, basically saying like there's just one system clock we care about and one automatic clock for typical commands. Logging, standard error, file system, random poll, TCP, sockets, and exit are all kind of interfaces that get pulled into the command world. So this is like, you can sort of define, this is what the world is like if you're a command. It's like you have access to these APIs. In the fullness of time, you can imagine a command actually has a few more things like this. Things like access to the time zone has actually been a topic that's come up in a few places, or access to like the user locale or other things like that. So there's potentially other things that could fit in here, or maybe access to like terminal APIs to do terminal manipulation could be part of this, depending on how much we can get in. But basically, the idea is like this is the world that a default command will execute in, and these are the APIs that are available to it. And then the last part of this is the function that is being defined in this world. And it is a function called command. And this is essentially the Preview2 entry point. So the command has a standard in, which is currently a U32 due to limitations in our bindings tools. You can see the to-do comment saying use the stream type from WASI poll, which will actually, the stream type is also going to be moving into WASI IO. Kind of a lot of like little details about what should live where that we're kind of still sorting out. But WASI IO, as I presented yesterday, is kind of the place where streams live. So I'll have to sync that back into this prototype to make sure we sync that up. And then we have the arguments. These are the command line arguments. In fact, it's just a list of string. And that's what command line arguments are. It's just a list of string. And then we have environment variables. It's a list of tuples of strings. So we got key value for the environment variables. And then we have the preopens. And so what the preopens are is it's the same kind of information that's getting passed to Preview1 preopens, where you're getting a handle and which represents a directory handle, and then a string representing the path that the libc should use to look up that handle. So when the program says, I want to open this file name, which might be a file name coming in as a command line argument or an environment variable, the preopens gives us the mapping to take that string and look up what's the directory I want to use for that string. So it'll give you the kind of like complete the loop of, user wants to pass in file names on the command line to open. And then the preopens give us a way to map those file names back into handles so we have handles to open things with in OpenNet. So that was my quick, very quick summary of what preopens are and how they work in Preview1. Let's see what we got for questions here, because that'll probably generate questions. Will WASI finally become a huge set of components, and how do we deal with them? So yes, WASI is going to be a huge set of interfaces, to use the terminology that we're using. So it'll be a large set of interfaces. In fact, we already have a pretty large set. If you've looked at the proposals.md file, it's in WASI. Let's see, in the WASI repo. I'll drop a link to it here. You can see we already have quite a few. Here's the proposals repo. We already have quite a few APIs in that repo. And it's the command set that we looked at here. We got files, sockets, random clocks, polling, streams, that kind of stuff. But we also have interfaces for WASI crypto. We have WASI NN, and we have and there's the WASI messaging and WASI PubSub, and WASI SQL is in there. A bunch of other APIs, and so that's a lot. And so that's where these world things come in. And so this world file that we looked at here, this world file is part of the WIT syntax. And so world files will then pull in the interfaces that are relevant to that world. So the command world will not pull in WASI SQL. Someone could make their own world that could have a command plus SQL, but the default world, the one that probably the WASI subgroup will standardize, I imagine, I don't speak for the subgroup, but I imagine that it makes sense to say like the default command, just like a default command in Unix, doesn't have an SQL API provided by default. If you want that, that's something you have to add, especially. And so even as WASI grows and have lots of different interfaces, I think different embeddings may not even want to implement all those interfaces, right? So if you're implementing something, in like a headless kind of configuration, like especially like in a serverless or kind of
live streaming is on.
All right, hopefully we're back here. Stopped. Hopefully we're back here. I know it's been about an hour, something along this pipeline. This happened in the previous days too. Something along this pipeline times out after an hour, and we have to restart it. So hopefully we're back online here. Okay, so I was talking about I lost my train of thought here. The world files. Yeah, so some embedding environments aren't going to want to implement all these APIs because we're going to have a lot of interfaces, and like maybe if you're an edge service provider, you're not going to want to implement all these command APIs because, for example, on the edge, there's not always a file system there. There's not always we don't always want applications opening raw sockets. For example, like the computed edge in Fastly's case, it's doing HTTP proxy stuff. Fastly is doing the TLS under the covers. We don't actually want applications running on top of this stuff to do their own TLS because that would prevent the CDN from doing its job. So we're doing the TLS under the covers. And so like in that environment, it's not a typical command environment. We don't even have the full file system API. We don't have the full sockets API. It'll just be the APIs that make sense in that environment. And so worlds are kind of a way of describing, okay, here's a set of APIs. Even though WASI itself may eventually have lots and lots of interfaces defined and standardized, we won't expect that every single WASM engine is going to implement every single API. We're going to say that WASM engines are going to pick particular worlds to focus on. So a command world for engines that are caring about command line environments, a cloud world for engines that are caring about a particular kind of cloud use case. And there'll be other kinds of worlds. Like maybe there's like an HTTP proxy world for this kind of like HTTP proxy interface that's going to have HTTP and other things that make sense for that kind of environment. So these worlds are kind of a way of taking subsets. Like even as WASI grows to have many, many APIs, worlds are this mechanism for taking a subset that makes sense to work together. And we'll really focus on making sure all the things in that world work together really well. Okay, so what would be the best repos for implementing Preview 2? I assume it's the ones in your GitHub. Preview 2 feels more decentralized than crypto. Yeah, so it is pretty disorganized. I have been talking about this Preview 2 prototyping repository. With some caveats, here's the Preview 2 prototyping repository where I and others are prototyping all this stuff. As I mentioned before, there are some things that are in this repository that are not synced up into the official proposal repos, and some things in the proposal repos that are not synced back into here. That's something that I'm going to be working on is syncing those up. But that's kind of the proposal repo where you can see a lot of the things I'm talking about here kind of in action. Not everything works yet, but like a lot of the things are being in the process of being implemented. That's kind of the main way to focus. Like if you want to follow like the day-to-day development, that's kind of where a lot of things are happening right now. Beyond that, you can also follow the proposal repos. So for things like WASI file system, the things I'm doing today are in my own fork of the repo, but this is the official repo. So if you follow this repo, you'll be able to see, when I take the changes that we're making today, I'm going to submit them to a PR. It'll be submitted to this WebAssembly software file system directory. So it's also another place you can watch. The proposal link that I also dropped above is also kind of a thing that has links to all the repos. So if you want to know where all the repos are, this proposal link can do it. I can also acknowledge that like it's kind of, with having all these different proposal repos spread out, it can be kind of hard to say, like, I just want to look at the entire WASI API as a whole. That's something that I'm expecting that over time, we're going to build better tools for. I think there are people working on like an HTML view of a WIT file that think will help. And hopefully what we can do there is we can have an HTML view of a world. And then what a world could do is a world could include the documentation for all the interfaces inside that world. I think that would really go a long way to getting people sort of the one-stop shopping experience for, like, as a developer, the world file is what you'll probably be targeting. You can sit down and you say, like, that WASI isn't a use case, but a WASI command is much closer to a use case. So, like, I'm going to build a command, or I'm going to build a thing that's going to run in the cloud, or I'm going to build a thing that's going to run at the edge, or run on a particular kind of embeddings. So you're going to sit down, and first thing you'll do is you'll pick a world to target. And then they'll say, okay, given that world, we can give you a generated documentation when we have tools for this kind of stuff that will say, here's all the APIs in that world. Here's the set of things that you can do in that world. Yeah. So the WASI Clocks repo is out there. I think the most confusing thing right now is that the repos out there use resources. And this repo that we have, the prototyping repo, doesn't use resources. We're using sort of this U32, which is just like an index into this implicit global table, which is not great, but we actually think that with BindGen is hopefully going to get resources and handles fairly soon. And so we'll be able to switch those things and get rid of the implied table thing. So yeah, it's kind of confusing. I'm always available. If you want to ping me on Mastodon, or I'm also on the WebAssembly Discord, or I'm in the Bytecode Alliance Zulip, ping me wherever. If you have questions about stuff, if I can help point people to the where to find things, I can always do that. And yes, over time, like, I think that Preview2, we're actually gearing up towards a pretty big effort to put out more documentation content and to really, like, help people get used to it, and not just get used to it, but like help people understand it. And so that's going to be, like, we know that the current state is not a lot of documentation. In fact, this live stream itself is in part about, like, starting to write more documentation and starting to go through these things and really, I'm as we're going here, I'm taking notes of the things that I need to sync up with the prototype. So working on getting those things synced up, taking notes on things that we need to document, taking notes that we think we need to clean up, and really getting them all kind of, like, cleaned up as much as we can so that we can start writing documentation and make it all clear. So that's where we're going. We're not all there yet today, but that's definitely where we want to go. Okay, so the pre-opens are roots as far as the directory history is concerned. Is the libc pathway stuff can only go through there? Yes, roots can mean a few different things, but essentially, like, the paths that are passed in as pre-opens are the only paths that a program can access. So programs don't have access to an implicit global file system or file system namespace. There is no namespace. There's just, here's some handles of directories you're allowed to access, and then here's a set of strings telling you how to map paths that you might have into those paths, into those handles. That's how the pre-open system works. I think actually I missed a question up high up above here. Let me go back and see if I missed something here. Let's see. Best repos for implementing Preview2. Yeah, I think I got everything. Let me know if I missed your question. I'm kind of trying to read the chat as it goes by live here and might be missing things. And I have a tendency, like, when people post new stuff, I have a tendency to jump ahead to the new thing and forget what I'm doing back in above. Okay. So yeah, so I've posted links to you can see the prototype, the Preview2 prototyping repo, where we're doing a lot of, actually, like, we're writing code to implement this stuff. And we have the other thing that's in that repo that's interesting is we have a Preview1 to Preview2 polyfill. And so what that'll let us do is take, there's a lot of tool chains out there that produce Preview1 binaries today. That's where we have, the Go, C#, PHP, Python, Ruby, Rust, C++, all have Preview1 support today. So we can take all those tool chains, and the idea is we can use this polyfill to wrap them up and produce a thing that will run in a Preview2 engine to kind of help smooth this transition. So we have that, and we also have the host implementation of the Preview2 APIs. That will eventually it'll form the basis for our WASM time implementation. So we're working on there. All right. So with that, I think we're through the questions that are queued up for now. And let's dive into yeah, in fact, I'm gonna make a to-do comment for myself here too. This is not in the official repo, so I'm not editing it here, but it's in the prototype. We have this concept of streaming. In fact, I can even show that here. So these are functions. Read via stream is a function where you give it a descriptor and an offset at which to read, and it will return you a stream reading bytes at that offset. So you have read via stream. You do the same thing with writing, write via stream, and append via stream. And so these are kind of like, this is the way to do streaming reads and writes on files instead of having like the file itself be a stream. That might be a good topic for another stream. I'm already recognizing that it's already 11:12 my time zone. And so we're probably not going to get through this entire file system API today. We'll have to have more streams about file systems and more streaming about sockets because we haven't even talked about sockets yet. So we'll definitely have to have more streams coming up, and I'll have to save some of that content for future streams. So detailed design discussion. Should WASI be file system case sensitive, or platform independent? So we went through this a whole bunch. We went back and forth on this. People tried a lot of different things to see if we could make this API easier to work with, less error prone. There's only so much we can do. Given that Windows works the way it does and Unix works the way it does, and even when you're on Unix, you can mount a Windows file system. It can have Windows behavior on the Unix platform. Things can vary on a directory, or even a file-by-file basis in some cases. There's very little we can really guarantee here. The nature of file systems is that the semantics are just all over the map, and so we're kind of like doing the best we can do, and we're not trying to be a hero. We're trying to give you kind of like what the platform does. There are potentially other things to say. I'll sort of leave this in here. Considered alternatives. This considered alternatives thing hasn't really turned out. Actually, maybe one alternative we can talk about really quick is like I mentioned this earlier, fully deterministic file system is something that we want to do at some point, or maybe makes sense for someone to do at some point. I'm not sure who might actually do this, but there's use cases for it. If you want full determinism and you want files, you might want to have this thing. And the main trade-off, I'll just type. Yeah. So there's things that could be done. That's not what this proposal is about. And I'm going to sort of leave this out here for now. We can add, okay, we don't need to have these comments here. We can delete these for tidiness sake. This section, delete the template content here. This should include a list of implementers who express interest in implementing the proposal. And so as the others, I think it's pretty obvious that WASI file system is pretty important to a lot of people, so we'll just leave it at that. I have people I need to thank for particular inputs to the process, but I don't have them in here yet. I need to make a note about, make myself about acknowledgements to people to recognize that have had significant input into the design here. So with that out of the way, we are basically done with the README. That was just the README. Now we have to go through the WIT file. That'll be the really fun stuff. Okay, question here. You might have missed my question about WIT bindgen. Okay, let's see if I can find it. A lot depends on WIT for this release. There we go. Can you comment on the current state of WIT bindgen and other critical tools and dev path timelines? Are there WIT implementation specs? So there are some things. We have a WIT. So what the WIT format itself is being defined by the component model. We have some documentation for WIT here. That's still in development, but it's actually kind of nice that that's being defined as a sort of separate level underneath WASI. we've known from the beginning of WASI that we didn't want to have WASI kind of grow up and grow its own little world of IDLs and conventions and ways of doing things. We wanted WASI to be built on lower level standards because ultimately, people will be doing things with WASM that aren't WASI, and they'll want to use the same conventions. They'll do many of the things, the same things that WASI is doing. So we want WASI to be built on like a lower level of standards. And now with WIT, we can do that. Can you also join the live stream? Yeah, everyone's welcome to. If you can click on the link, you're welcome to show up. This stream doesn't have a way of people like participating in the stream other than commenting. That's something I might change in the future because I kind of, like I mentioned earlier, I kind of am uncomfortable with this like feeling to get up on stage talking to an audience that I can't see. It just feels really, really weird. So I might try to like see if I can figure out something different to do in the future in terms of how live streaming works. But right now, you can come in, you can join, you can post comments in the chat. In fact, if you are asking questions in the chat, then you already are doing that. So we're currently working on a Preview 2 implementation for Dino. I already got Preview 1. We got Preview 2 once it lands. Yeah. So Preview 2 and with BindGen, I want to talk sort of finish answering that question with BindGen. So this Preview 2 prototyping repo we're building, that's built on with BindGen. And so we are using with BindGen. There is not a Jitsi link that I'm keeping open at this point. So right now, you just get to ask questions in the chat. That's where everyone's at. I realize that's suboptimal, but hopefully people can express themselves in typing. I really like interacting with people face-to-face more than typing. But for this stream, it's simpler for my setup here to just do everything in terms of the comment form here. So getting back to with BindGen. So Preview 2 prototyping repo that I linked to above, we are using with BindGen for that. Everything is based on with BindGen, and that's serving as one of the main vehicles for making sure that with BindGen has all the features we need to do what Preview 2 is, and then it's like it can do everything and make it work. And we're going to build a host implementation, and we have a guest implementation, the polyfill. So you have the guest side and the host side working with it. I'm aiming for a lot of this stuff to be demoable in like March timeframe. And hopefully beyond that, things will really start to stabilize very quickly. I'm hoping that March timeframe will include things like sockets and all the command APIs should hopefully be stable enough to have demos that people can run. It's kind of a rough timeline for things. So yeah, with BindGen is part of that story, and I and others that are working on it are sort of committed to make with BindGen work well enough to make those demos work. That's a big part of our thing right here. Okay, so let me know if I've completely answered your questions. This is one of the areas where I really missed having the sort of live feedback, is like when I can give people an answer and I can see if like they're nodding saying like yes, that makes sense, or if they still have more questions. I can't tell unless you ask me. So ask questions if you still have them. All right. Is there a Jitsi link? No, I'm not keeping Jitsi open for this stream. I think I talked about that. Does WASI Preview2 WASI move away from POSIX-based calls? Yes, it does. And if you've seen on the stream, you've seen some things already where we've moved away from POSIX in the earlier two streams, and that's definitely what we're doing. I should put a caveat on that. WASI libc is still a C library, and WASI libc will still continue to provide POSIX APIs. But the idea is that some of the POSIX APIs will become sort of emulation layers on top of what WASI is doing. So instead of saying like WASI itself is just going to do POSIX, we're going to say WASI itself will follow the path that makes sense for WASI. And then that libc to emulate POSIX will have to just do the best it can to get the best POSIX interface on top of that. The best example of that I have is actually this file streaming thing. Let me pull that up here. And this is in the prototype, but not the official repo yet. So I'm still working on syncing these things up. Maybe in a future stream, when I sort of finish the file system APIs in the future stream, I'll have these things synced up better. It'll be a little bit easier to see. But if you take a look at what I have on the screen here with read via stream, write via stream, and append via stream. And so what these are in is like there's the file system resource. These are methods of the file system resource. So you take a file, and you can say, give me the file. And file doesn't have read and write like POSIX would. File just has pread and prewrite. So the file kind of has no concept of its built-in position. That's kind of this extra bit of state that we actually don't want to manage. So the file is this stateless thing. The only state of the file is like the actual file system contents, the contents of the file, metadata in the file. There is no sort of current position state that has to get stored kind of in the middle. And so we have the ability to get a view. A read via stream gets you a view of the file that reads, write via stream gets you a view of the file that writes, and append via stream gives you a view of the file that appends. And it gives you a separate handle. So you have the file handle, which can just do pread and prewrite array things, stateless things. And then you can say that and you can get a separate handle to say, I want to stream through this file as reading, I want to stream through this file as writing, I'll stream through this file as appending. And then what WASI libc will do, and in fact, what we're doing in the polyfill repo, in this repo, because Preview1 follows POSIX, so we're actually doing the same kind of polyfill technique in Preview1, is to say that libc will have its own table for file descriptors. And that table will hold both handles. It'll have the file handle, and it'll have the stream handle you're using for the current stream. So if you call the libc interface of preread, it'll go to the file handle. You call the libc interface of read, the plain read that would expect to read from the current position, it'll read from the stream handle that libc is holding onto. So that's kind of a bit of area where Preview2 is diverging, because this concept of a stream and separating out a stream from a file, so we have a pure stream that is independent of what it's streaming from. I talked a lot about those in the previous stream yesterday. So having a pure stream that's independent of the thing that it's streaming from, where the user of the stream can't tell what it's streaming from, is actually going to be really, really important for a lot of our composing use cases. We want to be able to compose together components without having to have kind of this shared trust between them. We don't want to have a component have to trust that another component isn't going to peek through the stream to see, like, oh, am I streaming from a file or am I streaming from a socket? With the stream abstraction, once you have a stream handle, you can't use that stream to determine what thing you're streaming from. It's just a stream. It just has like pure streaming semantics. So that's kind of thing that makes sense for WASI. And to get there, it sort of requires us to make this break from POSIX. But then we can use libc, and we can use this Preview1 polyfill to basically do the same thing to implement the POSIX semantics on top of that. Okay, why Preview2 support gRPC calls, and if you address more light into the socket preview. So WASI Preview2 is kind of referring to this, it's pretty strongly associated with this command world. And the command world that I showed in the prototyping repo, and hopefully the subgroup repo will have something similar to this pretty soon. The command world, a typical command, if you think about that, like a command line command, would not have access to gRPC as an API. It would have access to sockets, because that's kind of how Unix does things. And Windows has similar APIs. So we have file system, we have random numbers, we have polling for things, we have TCP sockets. Eventually we'll have more than that, but this prototype doesn't have everything in it yet. The ability to exit and like clocks and stuff. But we don't have things like gRPC, because that's sort of not part of kind of the what we think of as like the command world. There are other WASI APIs. I linked to the proposal repo, and I'll drop that in again for people who are just joining us here. So you can see in this proposal repo, WASI as a subgroup is also looking at, especially in this phase 1 thing, we got blob store, we got crypto, we got distributed lock service, we got gRPC. In fact, it's right there. HTTP key value store, message queue, parallel, pub sub, runtime config, sockets, SQL. So we got lots of different things. And then the idea with the worlds is that we can take these APIs and we can make different worlds that can include different subsets of the APIs. So we don't expect that every engine is going to implement every API. That would actually be really hard and really heavy burden for a lot of engines that, especially engines that are run in specialized places. Like if you're going to run in an edge environment or run in a cloud environment, or if you just want to run in a command environment, you don't want to implement the entire, set of everything that the WASI subgroup might think about standardizing. You want to implement just the APIs that make sense in that environment. So the world mechanism is a way of saying, we're going to take identify a set of APIs. You can look at the world that's up here. Let's see. We're going to pull in this world file. We're going to identify these APIs, or the things that are available in the command world. And here's how you call a command, and nothing else. And there'll be other APIs that are available in other worlds. Like there might be a cloud world that would have something like a gRPC in it. The exact nature of what those other worlds are is still being figured out, but that's kind of the view for like how we can keep WASI kind of organized. It's like we have all these APIs. Some people want just straight gRPC. Some people want sockets, gRPC on top of sockets. Some people want gRPC on top of HTTP. People want different things. Different worlds can provide different APIs. And in fact, there's kind of even like 3 levels of overlap we have already. If you look at the APIs, we have things like WASI messaging, pub sub kind of stuff. And those might be built on top of, in fact, we have like 4. We have like that might be built on top of gRPC, which might be built on top of HTTP, which might be built on top of sockets. And kind of like at the WASI subgroup level, we have APIs for all 4 of those levels. That's a lot of things. And one implementation of an engine might not want to have all 4 of those levels because there's a lot of surface area, a lot of potentially security sensitive surface area. And so probably in most worlds, they'll like pick one level to sort of operate at. Or maybe you're allowed to have like the main level. You can also drop down a level. Worlds can certainly pick what kind of APIs they want to expose, but probably no world will expose every single API at once. So that's kind of the way of thinking about how gRPC, like there is a WASI gRPC proposal. It hasn't advanced very far yet, as far as I know, but it exists and people are working on it. But it doesn't necessarily preclude sockets. It doesn't replace sockets. It doesn't have anything to do with the sockets proposal, which is an independent proposal, which is moving forward. All right. I hope those questions, hope those answers make sense. I'm also struggling here because like I can't see anyone like nodding or looking confused or anything. I'm just like staring at an empty chat window. I have to just assume that no one's saying anything, so that means that people are happy with my answers. That's a good way to assume things. Okay. So let's dive into which. I'm going to upload this to my GitHub fork. And like I said, I've got some work to sort of clean this up and submit this as coherent PRs to the official proposal repos. And that will, in that process, I'll also do the work to sync these up with the prototype that we're building, so everything kind of stays in sync. That's some work that I have to do. It's fairly manual at this point, but there's kind of a lot of work to sort of shuffle these things around. And it kind of is an interesting question about like the standards process and like, is it worth working in this kind of context of like developing a prototype, but also trying to like specify as a standard or like a standards track proposal at the same time. It certainly is more work. But one of the things that I'm really, really committed to here is making sure that the outcome of this process is a standard. We don't want to end up in a situation where we have, individual companies defining significant parts of the platform. We want to have the platform be based on standards. And so we think that one of the best way to ensure that is to start building with standards from the beginning, rather than just saying like, we have our implementation and then, that's just our thing that we define by fiat, and we don't grow up with a process. We don't grow up with a subgroup kind of around that, controlling it. Right now, we do have a subgroup. It gets participation from a lot of different organizations and people, and that's a really great thing to build up. And that's actually one of the most important outcomes of this process, is to have that subgroup of people established, that we start from the day one with that group in charge of things. So, you'll be coming to the WASM.io conference. Yes, I am planning to go to WASM.io this year. It's at the end of March. Let's see what I can say about that. Do they have the talks, the speakers here? The speakers here. Yeah, so, okay. So wasm.io.tech, it's a conference that's being held in Barcelona on March 23rd and 24th. If you search WASM.io, you can find it. I'll be going there. I think it's gonna be good. And so that's kind of like, it's March. That's also kind of a time frame that I'm hoping to have. We can have some things ready. That'll be kind of a time when there's like a lot of special attention to WASI and things like that. So hoping to have cool things ready by that timeline. Okay, getting into WASI file system. We took an hour and a half going through the README, but that's good. It's totally good. I think it was kind of realistic to expect that it would take more than the time we had allotted here, given how things are going. So let's dive really quickly into the WIT. I think this will actually be a good chance to sort of talk about the WIT IDL and how it works, and kind of get a taste of this thing. WASI file system, and the wit.mb file is the file we're going to edit. Okay. So in fact, if you look at the WASI file system repo, I do already have a PR up to fix this size type. This size type has been there. It's in Preview 1. It's kind of been in WASI since the beginning because it kind of is the default thing that you get if you follow POSIX. You have functions like read and write that have arguments which are size t in C, which is basically like the size of an object in memory. But in the context of WASM, that's a little bit awkward to have a type like that because that means that the API is different. If we look forward between WASM 32 and WASM 64, we'd have like different APIs between those two things. And one of the big goals with WASM 64 is that we don't want to treat WASM 64 as like a separate mode of WASM. WASM 64 is just WASM. In fact, the name WASM 64 just refers to a toolchain convention of using a 64-bit memory. In terms of the WebAssembly spec, there is no WASM 64. It's not a separate mode. It's just the fact that you can have memories that can be declared as 32-bit or 64-bit, but the rest of the semantics is the same. There's sort of no like parameter or mode. And so it's kind of weird for WASI to have a type which would be dependent on the particular memory that the user has declared. And so I actually have a PR open to the public repo. I can actually pull up this. PR, remove the size type. And I'm proposing that we replace the size type with U64. So 64 bits is kind of widely recognized as like that's the biggest a practical file could ever be. Even like really big file systems that call themselves 120-bit file systems, individual files typically are not more than 64 bits worth of data. Strings supported as a data type. So strings and data in WIT, we have that today. That's working, and lots of stuff is built on top of strings as data in WIT today. That exists. It's not coming to WITX because WITX is basically not being developed at this point. It's kind of frozen in time. It has a concept of string, but it just basically referred to as a pointer in an argument context. So strings in WIT are there. They're implemented. They work great. You can pass your language's native string to them, and they work. So we got WASI file system. Size type is going to go away, replaced by U64. I'm proposing. I think that makes sense. What this does mean is that users of WASM 32, which is most people today, will need to be careful if they don't try to call read and ask it to read more than the amount of memory that they could allocate in their memory. I think this is okay because reading anywhere near 2 gigabytes in a single read call is kind of a lot. People probably shouldn't be using buffers that big typically anyway. So it doesn't seem like a big practical problem. So U64, it's a nice type that's big enough for all practical files and will be independent of WASM 32 versus WASM 64, and also versus eventual WASM GC. When we have GC languages that might not use linear memory at all, in that case, the kind of question of like 32-bit memory versus 64-bit memory goes away because you'll just have GC arrays. And in that case, like we want to be able to use the same WASI APIs for GC languages. And so we don't want to have kind of concept of the size of the address space baked into the API. So having U64 there instead of by size t makes sense. So that's a little sidetrack there. File size is the type that we already have for like U64. As I mentioned, 64 bits is enough for a file for anyone. You can quote me on that. File delta. This is just kind of, this basically corresponds to S or off T. This would be off T in POSIX. Kind of the offset within a file. I'm actually not even sure if we still use that. Oh, it's in seek from. It's in the function called seek from, although it turns out I'm going to be proposing to remove seek from. I showed earlier that how we have the streams split out from files. That means that the seek functionality, if you're a C program and you want to call seek, what seek really means is drop the current stream and open up a new stream at a new offset. So instead of saying like a mutable position that we're going to mutate, which is kind of how the POSIX seek works, we're going to say what seek is just a user-based concept of taking your stream and replacing it with a new stream at a new offset. So there won't need to be a seek from function, and we won't need a file delta. Taking notes as we go here. So that was file delta. Date time. This is actually stuff we talked about in WASI clocks. And some of this code is written in a place where we can't easily import types from one WIT file to another, but that's getting fixed. So we'll be able to go through and clean up date time and refactor that into a common WIT file that we can share between the file system and WASI clocks, because they both need this concept of a number of seconds and number of nanoseconds. And it's convenient, they can share the same type. All right, so descriptor type. This roughly corresponds to like the D underbar macros in POSIX, or the sort of ST macros in POSIX for the stat. So if you're in a file system, kind of the zoo of what can you find in a directory? You can find unknown things that aren't actually any category. It's kind of this wild card that allows us to deal with exotic operating system, which might have objects in the file system that we can't represent. Block devices are pretty obscure, and most programs will never interact with them, but they can appear, so we have a way of identifying them. Character devices, directories, FIFOs, or named pipes, symbolic links, regular files, and sockets. So this is a pretty common POSIX-y kind of set of things you can find in file systems. Descriptor flags. We talked a bit about this in the context of the example we're writing. So we have these descriptor flags for read, write, append, roughly correspond to the POSIX ORead, OWrite, and OAppend, or read only, OWrite only, and append flags. And we have the various sync modes. I will say that not much thought has ever gone into the desync, non-block, or desync, rsync, and sync modes in terms of what these actually mean and whether we actually can get this kind of functionality in a portable way. This is functionality. These flags we got from Cloudy BI, and they kind of exist in some sense in POSIX. But I'm pretty skeptical that we actually can get meaningful guarantees about data synchronization and integrity out of these flags in a portable way. But they're here for now, and that'll be something we can investigate over time. And I made a note myself to go back and investigate semantics for these things. Non-block, I think I also made a note for that also. Non-block, because actual file system implementations in practice don't respect the non-block flag for files. They only respect it for sockets. And so it's kind of dubious that we should have this flag here. Okay, descriptor stats. This is basically like the stat structure in POSIX. It's called file stat in Preview 1. When I say earlier versions of WASI in this document, I'm talking about Preview 1. So descriptor stats, we got device, inode, descriptor type, that's the type we just looked at above. The link count, end link is a POSIX thing. File size, access time, modification time, and status change time. One thing we don't have in here is the birth time of the file. Some file systems have a concept of a birth time, but I think that's not quite as portable, so we don't expose it. And then, of course, device and inode. I want to call out, there's another issue here. We have removing the device and inode numbers from the API. So if you're interested in this topic, definitely go check out this PR, and I'll drop this into the chat. Device numbers and inode numbers are kind of this long-standing POSIX thing. It's a pretty common technique in POSIX to use the device and inode number pair to identify the identity of a file. If you have the same device inode number, you can be sure that you have the same file. But it turns out to be pretty weird to expose those things. They're actually kind of very low-level implementation details. They expose potentially some potentially sensitive information about the host file system. WASI file system is designed to allow you to expose parts of a file system to a program and not other parts. But if you can observe inode numbers, you could potentially observe things about what other things are happening on that file system, or what kind of file system it is, or what else is stored in that file system. You could potentially observe some of that from the inode numbers. And so, exactly how much you could get is kind of a complicated question. But it seems like what we really want to do is just hide that from the user completely, because it's like this non-deterministic thing that has almost no meaning, except for this identity kind of property that you can use to say that one file is the same as another one. And so my proposal here is that we get rid of the device and inode number, and we replace it with this thing called the metadata hash. So the metadata hash works by having the implementation do a hash function on the device and inode number, and potentially other information. That's where we could actually use the birth time, could kind of feed into that. Anything that kind of like uniquely identifies a file in some sense. except that it's presented as a hash function, so the applications can't actually learn anything from it. The actual information about the actual inode would be hidden in a hash function. So that's kind of my proposal. It's out there. This one will probably stay open for a while because we're getting a lot of feedback from this one, and it's good because it's kind of one of the biggest changes, kind of a big departure from POSIX to get rid of inode numbers and device numbers. So we'll leave that one open for a while, collect more feedback. So far, it seems like there's been a lot of positive feedback about removing these things. And I'm interested to hear from people who think that we should keep them, or who think that the metadata hash function isn't good enough. Any reason why we shouldn't do this is kind of particularly important to hear from now. Okay, so let's get back to, we'll leave guys an inode number for that PR. We'll come back to those things. AT flags. We talked about these a bit at the beginning in terms of the examples. We have flags. POSIX actually has a bunch of other AT flags that you can actually specify to some functions. There's like, Linux has a whole suite of AT flags, but most of them aren't very portable, or they don't apply to many functions. So AT symlink follow is the one that makes sense. I can also point out here that POSIX actually has two different flags. There's AT symlink follow, and there's AT symlink no follow, because some functions in POSIX default to following symlinks and others don't. And so the ones that default to following symlinks, you need a flag saying don't follow them, and the ones that do, you need a flag saying do follow them, or the other way around. And in WASI, we're actually kind of following this. This is actually one thing we are preserving from Cloud API, is kind of this concept of like, let's just have everything default to no follow and have a single flag for follow, so it's all kind of consistent. Not really necessary that we do that, but it does kind of feel nice to have things be consistent, to say like symbolic links are either going to be followed or not based on this flag for all functions. It's kind of a nice property to have. All right, O flags is for when you're opening a file. And so like there's actually an interesting distinction between the O flags and the descriptor flags. In POSIX, these are all kind of like dubbed together. They're all the O underscore flags, like one big set. But some flags are only relevant at the point when you create a file. If the file doesn't exist, do you want to create it? O directory in POSIX is a way of saying like, I want to open a directory, and I want you to fail if it's not a directory. That only applies at open. The O exclusive flag fails if the file doesn't already exist. In fact, let's just, because we can demonstrate how this works, let's rename that to exclusive, and just like type it out, and then truncate. Let's fix that spelling too while we're here. I'm gonna call it truncate. Even though POSIX calls it OXGL and OTrunc, we can call these things exclusive and truncate just because we can. So truncate file size is 0 at the point when you open it. So these are all things that happen at the point where you're doing an open. And descriptor flags are all sort of like things that you get. The descriptor flags here are things that are sort of applied to what you can do while the file is open. The mode refers to, it sort of refers like, because POSIX calls it a mode, but it's like the permissions for the file. Do you want to open the file and make it readable, writable, or executable? There's also a PR or an issue, at least. I think it's an issue about user-only permissions. So there's this issue that's opened. It's kind of a complicated issue, in part because of the Windows issue. If we expose things like POSIX, user group, other, we have to decide what does that mean on Windows, which doesn't have those concepts and has different concepts of its own. So we have to decide what to do there. That's what's going on there. And keep going here. Link count, device number, inode number. Those are, talk about those. New timestamp. So when you set a timestamp on a file, you can set it to I guess we'll talk about this more when we get down to the set file times function. Directory entry. I think there was actually a question about this earlier that I missed about, is there a way to read directory entries in a way that doesn't return too much information, that requires Windows to provide too much information? I think if you look at this directory entry struct here, I think you'll see that showing up. Especially if we look forward to that proposal of removing inode numbers and the inode goes away, we'll end up at a place where the only thing you get from a directory entry is the type. You get to know if you've got a file, a directory, or something else, and the name. We're really not going to give you any other information besides just that in a directory entry. That is what almost all use cases want, but we won't sort of force applications to provide more. It's possible in the future we could imagine having a like extended directory entry and an API to say like I want to iterate over the directory and I want to get like the extended information for all the files as I go. But I think for the default use case, for the default like I just want to iterate through directories, almost all users just want to get the names of things, get the type, like you need to know if it's a directory or not, and then you want to know the file what it is, and you might directory or symlink or something else, and you want to know the file name. All right. Erno. So this is the file system Erno. If you are familiar with POSIX Erno, you'll recognize almost all these codes here. One thing that it's notable here is that we don't have the network Erno codes in here. So we don't have, WASI as a whole is not going to have a single unified Erno across all of WASI. Every API, every interface will define its own error types for itself. And so file system just has the Erno codes that apply to file system functions. We don't have every single Erno thing that will ever exist. And then, of course, in libc, which is going to, its job is to prevent the POSIX interface. And so in POSIX, there is a single error node space. So libc will actually be taking these error node codes and the socket error node codes and sort of appending the socket error node space into the file system space to sort of synthesize a single error node space. All right, we'll talk about advice and the concept of fadvise when we get there. Seek, we talked about that a little bit already. Descriptor is the main resource that's all organized around. We talked about that a bit already. fadvise, yeah, we have 12 minutes left. I'm like racing against the clock here to see if I can get through this thing. But realistically, I know we have to revisit this anyway. So I'm gonna get through a few more things here and then probably wrap up. And then I'll schedule some more live streams in the future. So let's talk about a few more things here. What we hear, it looks like there's a taste of that. This is like the first actual function in WIT that we've looked at. So it'll be a good thing to look at. So we got a function here, / documentation comments. We really need to write more about this. I'm not going to have time to do that in 12 minutes, but this is actually one of the big things I wanted to do in these live streams, is sort of sit down and these comments we've sort of had since the Preview 1 days. We kind of sketched up, and it's kind of assuming that you basically know what POSIX fadvise does. And if you kind of know that, you kind of squint into this thing, you can kind of see how things line up, and kind of just this massive hand wave for how these things should behave. We've gotten a lot of questions over Preview 1's lifetime about, what is this stuff? Like how exactly does fadvise behave? Like why is there no documentation that stands alone? And so I want to do more of that. I'll do more of that in live stream. It's not going to happen in the next 11 minutes. But I'm going to make a note to start at fadvise. A place to start writing documentation comments. I think I'm going to use the rest of this time to just talk through a few more things in this stream, because it seems like it's the most useful thing. Here, check for questions. No questions going on here. Looks like we have, all right. Data sync flag, where we at here? Oh, we are at, okay. Descriptor, advise, data sync, data sync and POSIX. This will be an interesting one because like the semantics of syncing things is going to be very complex, and especially in a portable across a WASI context. Flags, we have some things that are similar to, so like fstat kind of and fcntl for getting the flags and the type, things like that. Pread, pewrite, reader. I'm realizing that I'm kind of jumping ahead. I'm kind of realizing that I'm not really thinking that we're going to write a lot of things right now. And what we really need to do is actually spend more time to dig through in more detail, see if we can be more mundane live streaming, like the most mundane live streaming that you've ever seen. It'll be like documenting all the file system functions, but that's what we'll do. So I'm going to walk through these things and things like create a directory, and we don't really say what that means or what you can expect. Or I guess in this case, it's pretty clear what you're going to get. You're going to get a directory. It's going to have this path. So it's a lot of this kind of stuff. If you know what these APIs do, you can kind of guess. And that's kind of how we've worked so far, but we really need to step up the game and get to a better place. Stats is like fstat, statat. It's the times I get. Anything else that's worth kind of calling out here? Oh yeah, I want to call out the lock functions. That'll be a good thing to talk about in the last few minutes here. So lock shared. So one of the things that wasn't in Preview 1, a file system functionality that's actually pretty common, but we didn't have in Preview 1, was the ability to have file locks. And actually, that turns out to be pretty nice to have for a pretty common use case like SQLite. And so what we're adding here in WASI is the ability to have functions that can request a file lock. So you can lock a file. And that way, if you have like multiple SQLite things going on, they can lock the files so they can prevent each other from collaborating each other. So it's not in WASI Preview1, it's in Preview2. And I think this is actually the last function we need to allow sort of regular SQLite to run on top of WASI, which I think a lot of people will like. So lock shared, lock exclusive. Basically, this is like shared is for read-only access, and exclusive is for read-write access. I think that's talked about here. There's a typo. Let's see if I can find that typo here. Fix that while I'm here. Try shared lock. So you can, so these lock exclusive, lock shared will block. Try is just going to try one time and give up immediately, and then of course you can unlock. So new functionality that's not existing in Preview 1 that I think is going to be used by a number of people. So with that, I'm going to wrap it up. My throat is actually getting really dry. I'm talking more, like this is more talking than I typically get to do on a regular day. So talking for the live stream, but that's good. This is what we're set up for. This is what live streaming is all about. So thanks a lot. This is actually the last day of the live stream. And so I should talk about like going forward what the plan is here. I still have a lot more work to do in WASI file system. And I have a lot more work to do to sync up these repos with upstream repos and more things I can talk about. So I'll plan to schedule some more live streams. I don't have anything I can schedule on stream right now, but I'll post on social media. I'll post in my YouTube channel here. I'll post the schedules for upcoming streams so we can talk about when we're going to finish file systems, when we're going to go through sockets. And if people like these streams, we can also talk about other topics we can do on stream. And we also potentially talk about other formats. I know one person was asking about, can they join the JISI thing, which would be kind of cool. And maybe we could just do it. I just couldn't really think on the fly whether it actually would work with our current setup or not. So maybe that's something we could do in the future, is like just open up the JISI stream to let other people join in. We'll figure that out. So things to look forward to in the future. Follow me on Mastodon. It's in the live stream. I'll drop it here just because it's good to put that link anywhere. Oh, and that calls up some more comments that I didn't get to. It'd be great if I have 6 more minutes on my own schedule, and I guess many people have dropped off at this point, so I'm not sure who's paying attention, but I'll answer it because it's going to be on the live stream. It's all recorded. It would be great if the generated markdown for Whitney enums would enumerate the numbers of each option. So you can read and look up the value without counting. Yeah, so we actually have the WIT-MD file while I'm still on stream. So there's the in the repository, the way things are currently set up, there's the wit.md file. That's the manually maintained markdown wit hybrid thing we talked about at the first stream. And there's also this .abi.md file, which is actually generated. And if we look at this one, we have something like the enum cases. Oh, it doesn't have the numbers in it. We have the size and alignment in this thing. We don't actually have the numbers here. So if you're looking up the numbers, if you're working at the canonical ABI level, you want to see what these integer numbers are. We don't actually have that documented yet. That's something we should fix. We have .abi to document the enum numbers. That is a good idea. Okay, one more question. In case people are still listening in the last 5 minutes here. Why is path in these APIs a string and not a specific path type? That's also a great question. So string in WIT is a Unicode string. It's a sequence of Unicode scalar values. And so what we're saying here is that all the file names have to be Unicode file names. I am saying this with full awareness that that is not the POSIX way. And that there will be a number of people who will have use cases, most likely, that will find that they have file names that are non-Unicode file names. And we'll figure out how to deal with those. We actually have a couple of different plans for how to deal with that. I have a proposal, sort of design sketch, for a thing called arf strings, which you can see here. Put this on the stream because it's kind of fun. And this is a way of encoding non-Unicode file names in a Unicode string. It's just a SketchUp prototype at this point, but it's kind of one potential way forward of way we do this. Another option is to simply say that those file names are just not supported in WASI. WASI program just cannot open programs with Unicode paths. And so this is the kind of thing that we can say because we're kind of stepping away from POSIX. And we can really say that, like, in a portable program, if you have non-Unicode file names, those are very difficult to deal with from source languages that have different string types. We need to know the encoding of the strings in order to be able to translate them into the proper string type for your source language. And so Unicode, it could be UTF-8, it could be UTF-16, but it has to be Unicode. It has to be a well-formed Unicode string. And that allows us to do this transcoding from whatever the file system Unicode encoding is to whatever the source language Unicode encoding is. It might be UTF-8 to UTF-16 or UTF-16 to UTF-8. We can do a lot of combinations. We can transcode things, but we need to know what both sides are. We can't ever have a situation where it's opaque bytes, because then if the source language wants UTF-16, we can't translate opaque bytes into UTF-16. We don't know how to represent that. And it's the same thing for, like, if we have bytes that aren't going to UTF-8, and we want to translate it to a source language that wants UTF-8, we can't directly translate those things very easily. So the current plan is to say that these are strings and just say that non-Unicode file names are unsupported. If we have use cases that really need non-Unicode strings, we could do something like ARF strings. And that's kind of the current level of thinking about this. All right. That was a very quick sort of impromptu explanation of that. There's probably a lot more I can potentially say about that. That's kind of like the current off the top of my head view of things. And for that, I'm going to wrap up the stream here. I got 2 minutes left to my original timeline, and say thanks a lot for everyone showing up. And thanks a lot for everyone watching this on the archive. This will be recorded, and you can watch it later. And so thanks a lot. Reach out to me on social media if you have questions. This stream is like totally impromptu, and this whole stream series has been my first ever live stream series. I didn't even have too much chance to practice this thing, so I feel like I'm totally winging it and making mistakes on the fly here. So anything I say that doesn't make sense, it's probably because it doesn't, probably because I said the wrong thing. And look forward to future streams. Thanks a lot.